Hi, this is a review video on polynomials and rationals. Polynomials are equations like what you see on that graph paper type picture, where you have different powers of x in combination with multiplied exponents, and then terms are added and subtracted, and that makes a polynomial. Polynomials can be as short as just one term. For example, if I just had 6x to the fourth, that's it, that would still be a polynomial. So, but they can have many terms as well, like the 3 terms that you see in the example on my screen. The other type of equation in this video is rational equations. This is a unit that we did pretty recently, and you will have things that are proportions, like the one that's on the screen right now, where you can just cross multiply. Sometimes that cross multiplication leads you to have a polynomial, which is why we thought we'd put these two topics together. There also are rational equations where you don't cross multiply because you have an addition or a subtraction involved in the equation. So you have multiple fractions, not just 2, but maybe 3 fractions. And we have an example of that in this lesson. It is the last one. Okay, so here's the first one. This one says solve the polynomial equation by factoring. Before you factor, you have to have equals 0. The whole purpose of factoring is that you have things multiplied together equals 0, which means that one of the things has to be 0. So 0 is a critical piece. For this to be set equal to 0, we're going to move this 18 over by adding 18 to both sides. So that will be our first step. When we do that, we combine the 42x with 18x to get 60x. Then we want to start factoring. Whenever we're factoring, we want to ask ourselves if there is a greatest common factor we can take out first. Doing that first is going to make any other factor that we have smaller in values, in like the number part, and that will make the rest of the factoring easier. So we always want to try to do that first. And in this case, there is a greatest common factor. Do you know what it is? You're right, it's 3x. So we'll take out 3x. And then think about as if you were to be distributing 3x times blank, 3x times blank, 3x times blank. What is it that would lead me back to that line that's in blue? Okay, now we need to factor the part that's in the parentheses. This is a good old classic, what multiplies to 20 but adds up to 9. Write on your paper what you think it will be. Okay, I hope you picked 4 and 5. Okay, so this is our factored form. I now know that it's factored because there's no way to break x plus 4 down more or x plus 5 into some other multiplication problem. And so now we use the power of 0, right? 0, my hero. U set equal to 0, and then U set equal to 0, and then U set equal to 0. Each one. When I set each of those factors equal to 0 and solve, I would get these 3 solutions. Okay, let's look at problem 2. Problem 2, is there a GCF? There is not a greatest common factor in the entire expression. However, this has 4 terms, and we're going to use the idea of grouping. And grouping kicks off with thinking about greatest common factors. In the part that's underlined in blue, if that were the entire question, what would be the greatest common factor? X squared. And for the red, what would be the greatest common factor of those 2 terms? 4, perhaps. Okay, now in grouping, whatever is left in this parenthesis has to be in the other parenthesis as well. When I factor out x squared, I'd be left with x minus 3. So if the other parenthesis is also x minus 3, notice that the 4 that I take out actually has to be negative. That makes negative 4x. Negative 4 times negative 3 makes positive 12, and that is what I see up there. Okay? So this is my first move in factoring by grouping. Then think of this part of the problem and this part of the problem as 2 chunks. Both of those chunks have x minus 3. Take it out as if it were a greatest common factor. From the blue, you'd still have x squared. From the red, you'd still have minus 4. And now we are really looking good for factoring. This part factors a little bit more. I'd like you to pause the video, finish factoring, solve, and then come back. Okay, we left off right here in our process. So I hope you factored the x squared minus 4 using difference of two squares. X plus 2 and x minus 2, either order is fine. And then set each factor equal to 0, and you should have found those three solutions. Okay, in our next problem, this has a leading coefficient that is not 1. So in this case, some of you might be able to just write out parentheses and say, okay, well, 2x times x makes 2x squared. And then think about numbers that multiply to 7. Think about this and this combining to make negative 13x. If you can do it thinking through it, that's just totally fine. But a lot of us maybe have a hard time doing that. So we have taught you the technique of split the middle term. So you'd multiply the leading coefficient times the constant. So in this case, it's negative 14. You want to think about pairs of numbers that multiply to 14. Then you want to look at the middle term. Think, how can I use one of those pairs of numbers to generate the negative 13? The way that you would do that is to assign signs like this, and then you're going to split the middle term. It's a very descriptive name. You're going to keep the front and the back, and then you're going to take that middle term and you're going to split it the way that this part indicates. So 1x minus 14x is the same as having negative 13x. Then you factor by grouping. I'd like you to pick up from here by yourself and try to finish the question. Come back after you've tried the question yourself. Okay, I understand that you absolutely could, just cut corners and keep watching, but that's not getting better, okay? You're watching this review video because this isn't necessarily a strength of yours right now. So to get better, make sure you pause, try, and then come back. Okay, I have left off with you about here. And so you were doing the grouping. And so out of the terms I have underlined in blue, the greatest common factor would be x. And then I would have 2x plus 1. I have 2x plus 1 in the second parentheses, then the 7 that I pull out has to be negative. My two factors are therefore 2x plus 1 and x minus 7. And we're going to set each of those factors equal to 0 and solve. One of my solutions will be negative a half. Subtract 1, divide by 2. The other one will be 7. Okay, that is our review of polynomials. The other two questions here are rational equations. Rational equations, remember, just mean that you have a ratio. That's what word is hidden right in there. So a ratio that has x's in it is involved in the equation somewhere. The easier, more straightforward kind of rational equation is called a proportion. It's where you have a fraction, it has to fit this form, an equal sign, and then another fraction. If it's anything different from exactly that, it is not a proportion. Sometimes you can tweak or adjust an equation to put it into the form of a proportion, but if you can't, it isn't one. You can't force it, right? So we will see an example here that's a proportion, and the last example is not, okay? When we have a proportion, we multiply these two things, then we write an equal sign, and then we multiply these two things. So our first step here is this, multiply, set equal to, multiplying the other direction. Okay, I'd like you to pause the video and come back when you finish solving that linear equation. Okay, so you should distribute the 4. On the other side, the 5 with the 2x. That means 5 times 2 times x. 5 times 2 is 10. So 5 times 2x is 10x. Then just go from there, right? Move all your x's to one side, leave your plain number on the other side. X should be 4. And then if you think about that solution up here, there's no dividing by 4 that, or dividing by 0 that's going to happen when x is 4, so we're good. We're absolutely good. This last problem is a lot, okay? I'm just warning you of that because it is, okay? Now, this isn't a proportion as it stands. I don't see a way to tweak it to make it a proportion. So what we want to do here is think about what denominators we have, because what would be a common denominator, I'm not going to actually use it as a denominator. I'm going to use it as a multiplier and multiply the whole equation by that expression, and it will get rid of the fractions. And then once I'm done with fractions, I'll have a different type of equation, maybe a linear, a quadratic, a polynomial, but something else that I already know how to solve. This 4 could be thought of as a fraction, 4 over 1. My denominators are x plus 4, 1, and x minus 1. So the thing that would be a common denominator is the expression x plus 4, x minus 1. Technically, you could also have a 1 there, but that's just more writing, okay? Multiplying by 1 doesn't really change anything. 1 is very unimportant in this aspect, okay? So we're going to take that quantity, and each of the 3 chunks of this problem are going to have this multiplied by it, this multiplied by that, this multiplied by that, okay? Some people find it confusing to have fractions and then this thing in red that's not a fraction. If that's you, think of it like this, just like we did with the big 4. You can make anything look like a fraction if you just put a 1 on the bottom, okay? And again, you would take all of this times this fraction, all of this times this fraction, all of this times this fraction. That's what's going to happen, okay? Now, because this is a long problem and I didn't want the video getting longer, I have already written out this problem. And so I'm just going to walk slowly through it, okay? And I'll try to give you enough time to write. If ever I am, you don't have enough time, remember it's a video. You can pause, okay, and get everything down that you need to get down. It's important to be organized in your work. Here's our first step, okay? So this is what I was describing back here when I said we would take this expression and multiply it to each of the 3 pieces. So on this slide, the thing that I'm multiplying through by, I wrote in blue. The original problem I wrote in green. So you see, like, just look at color for a second. This line of writing has 3 things in green. Those are the 3 parts of the problem you had originally. And then next to each of them, I wrote x plus 4, x minus 1. Okay, at this point, we are going to very carefully cancel out the things that cancel out. We should have no fractions left after this. Okay, so in the first piece of the question, I'll call it a chunk. In the first chunk of the problem, x plus 4 cancels. In the second chunk of the problem, you might say, well, hey, that 1 is still there. The 1 we just put there to have everything be a fraction. 4 divided by 1 is 4. Right? So that's not really a fraction. Okay, it's not convenient for it to be a fraction now. And then in the last piece, x minus 1 cancels x minus 1. So if you look across from left to right, I know I'm on the right track. This isn't there, this doesn't need to be there, and that's not there. We got rid of all of the denominators. Okay, in the next step, I mostly just recopied. Okay, so let's take a look at that together. These 2 things I just highlighted in blue, that's what you see right underneath it. 6x with x minus 1. I put the 6x first just because I'm thinking about what I'm going to do next. That looks like more of a distribution problem to me, okay? Equally would be fine if you wrote it in the other order though. Over here, this 4 is here, okay? And then the part in blue, x plus 4, x minus 1, I multiplied that out. Right? Distributing, FOIL, yeah. Okay, on the right side of the equation, the 2 pieces I still had were x plus 4 and 2x plus 2, and I just copied that down. Okay, the next step is going to be a bunch of using the distributive property. On the right side, the type of distributive property we sometimes call FOIL is on that right-hand side, okay? So take a second, pause the video, see if you can get just the next step, okay? In the next step, you're going to distribute, distribute, and then do FOIL over here. Okay? So pause the video, come back and see if your next step is right. Okay, this is what I got. All the stuff in red is what I got from distributing. Distributing 6x, distributing the 4, and then doing FOIL on the other side. You might have 8x plus 2x instead of my 10x. That's fine. No big. Okay, now if you look at my color coding here, I underlined everything that had an x squared. And you need to be aware that this is where the equals is. Okay, so you can't combine like terms just going left side stuff with right side stuff. You're trying to combine like terms but also move, things to the left. Okay, so for example, 6x squared plus 4x squared is 10x squared, but I have a 2x squared on the other side. So 10 on one side, 2 on the other is going to make 8 on the left side, 8x squared. For the blue terms, I have negative 6x and positive 12x on the left. So 6x squared on one side and 10x on the other side makes negative 4x. And then I have negative 16 on the left and positive 8 on the right, which is negative 24 on the left. Okay, so that step is just really combining like terms, moving everything to one side so I can have equals 0. This is now a polynomial equation, friends. We were just talking about polynomials just a few questions ago. So here we're going to take out a greatest common factor. What would that greatest common factor be? I wish it were 8. It is 4, though. It is only a 4. So take out a 4, and then the part that's in the parentheses, you might be able to just factor by thinking it out. And if you can, I am proud of you for that. If not, you need to do split the middle term, which we also just talked about moments ago. So my special number for split the middle term in this problem is going to be found by taking 2 times negative 6, which is why I have negative 12 written over here. 12 is 1 times 12, or 2 times 6, or 3 times 4. And what works well for a middle term of negative 1 is the 3 and the 4. Make the 3 positive, make the 4 negative, and those add up to negative 1, which is what my coefficient on the middle is. So split the middle term, and then do grouping. Okay, if at any point you want to practice yourself, feel free to pause and try, and then come back and see how you did. So out of the first group, what would be my greatest common factor? Should be an x, leaving me with 2x plus 3 in parentheses. And if I want my other parentheses to also have 2x plus 3, I need to factor out negative 2. Now I think we've got it factored, my friends. Both of these pieces have this common factor. So that's a factor, and then the leftovers are a factor. X minus 2 is my other guy. So 4 and x minus 2 and 2x plus 3. Set each factor equal to 0, and you're home free. That's a mega problem. This is a really long one. Holy cow, okay? So remember that you need to show your teacher your video notes. If any of the questions in the video were confusing to you, that would be a good time to talk to your teacher and say, hey, I need some help. That last mega problem was scary. All right, ask questions. That's how you learn. Make sure after that you have shown your teacher your notes that you go ahead and work on the problem set. Don't take out your phone. It is such a time suck, such a time waste, okay? Get your work done now so that at home you can have some leisure time, okay? And then, as usual, the problem set needs to be included in your portfolio. Thank you.